Hello everyone, today we'll be taking on homework assignment number 2 with the problem number being 8 for this PanCAPS assignment. This assignment reads, figure example 21.8, which has a little image below that I try to replicate the best of my ability, shows a standing wave that is oscillating at frequency f0. And the first question of this problem says, how many antinodes will there be if the frequency is doubled to 2f0? Explain. Well, first off, we have to count how many antinodes this first wave has. This first wave has 1, 2, 3, 4. 4 antinodes. All right. Okay, now what we want to do is we want to go from frequency f0 to 2f0. Before we do that, we want to then put our attention to what can we relate to this oscillation, or we can say that velocity of any wave is equal to lambda frequency, right? From there, we then take a closer look at the example and says that this is a standing wave. From a standing wave, we note that then that velocity is equal to the square root of tension of the string divided by the unit per mass length, which is mu. Knowing that for a standing wave, the velocity is depending on these two variables, we can then say that since there's no mention of those two variables within the problem, that velocity in both cases from f0 to f0, we're saying that velocity is not changing. Hence, we can then say that for frequency f0 at a certain wavelength, we have velocity, and that same velocity applies to 2f0. Lambda is equal to the same velocity, right? So in order to go from f0 to 2f0, we know, and knowing that velocities are staying the same, something is going on with lambda. And what is that? Well, the best way to explain this is let's substitute some numbers for this top equation first. Now, going in simple order, we have, let's say, 2 for the frequency, 2 for lambda, and this production, or this product, is equal to 4. From there, we are then going to be like, okay, well, this frequency, as based off what we wanted to do here, is we want to double it. And based off the equations that we have here, we prove that velocity in this equation will stay the same due to it be velocity dependent on tension and unit per mass length. So we know that our product here, our second product, will be equal to 4. So in order to make 4 times something equal to 4, we know that then we have to make it equal to 1. And therefore, we have done basically what we've done in these equations. We've gone from a frequency of 2 to 4, which is doubling, and then we've gone from a wavelength of 2 to 1 in order to get the same velocities. What that entails visually is this, is that we're then going to be dealing with, if we look at the general equation, if we double frequency, we're going to, in a sense, half lambda. And since in lambda we have 4 waves, or a wavelength of, I guess, technically 4, well, not really, but what's going to end up happening is we're going to be reducing these wavelengths in half, meaning we're going to be able to fit twice as many waves in the same distance. 3. So after multiple attempts at trying to get the right answer or get the right drawing, we have completed that, where we have 8 antinodes. 1, 2, 3, 4, 5, 6, 7, 8. So to answer the question is how many antinodes will there be if the frequency is doubled, we go from 4 antinodes in the original drawing to 8. So we basically doubled the number of antinodes. Thank you and have a good day.